Hey, guy. What you do?
One of my mom's friends said of that picture of Arthur that, boy, Jen, you're going to have to keep the ladies away from him. I said, I've probably got at least until he's out of diapers before I have to worry about that.
Yeah, that's...
Most ladies don't want someone who poops their pants.
We got a while. That's good. Tankathon 2018. Amazing. Alright, guy. How you doing? Aww. Really? My guy. My guy. Oh, you're so sad that we give you so much food. Oh, it's just like, oh, food? What is food? I've seen you eat so much. You eat so much. But you, I don't know what's in. How much are you supposed to be eating? I don't know. Okay. See,
But
that's what happens when you go too hard. Is you just puke all over. Oh, hey. By the way, I started a live stream.
Oh, should I turn off all the noisy things I have in the background?
Nah, there's only one person here. But I do have one student watching me
Feed your baby.
feed my baby.
You want me to take him?
At this point, it kind of chilled out. I don't know why I'm typing this. I could just talk to you. But it's weird for me to think about that. Oh, hey. Another person came by. Unless that's Halima. Don't actually know. So, Halima, how's it going? Yeah, he is pretty cute. He's so hungry this afternoon. Just finished giving him like 2 bottles. At least he's finally calmed down a little bit. Do you have any questions for me, Halima, or are we just here to watch me hold Arthur? Because, I mean, that's kind of a way to spend my time, but, you know. What the fuck again? Oh. My God. I may have to switch to a bouncy ball. He tends to like bouncing. But I'm still with you. On the festival, I can. Yeah, I could see you coming for Arthur. He just likes bouncing so much. The problem is I can never stop moving. I hope other people come. I hope it's not just me digitally hanging out with a student after school. I guess that is how like office hours work in like college. Usually just like mostly nothing, and then one student stops by. Links? I don't think it's links. Oh, ln x squared over x dx? Yeah, okay. So we've got alright, so this one's pretty complicated, doesn't seem to match. Some clues about what to do is this divided by x plus the dx is pretty distinctive as the result of taking the derivative of ln of x. So that suggests our substitution is going to be u equals the natural log of x. In that case, du is 1 over x dx. Oh hey, we've got 1 over x dx here. We got u there. So this becomes the integral of u squared du, which is 1/3 u to the third plus c. When you substitute back in, it's 1/3 natural log of x to the third plus c. No, I gotcha. Whoosoo. That was a fun noise you just made. Oh, hey, has someone else joined? For the person who just joined, I'm bouncing because Arthur is being kind of fussy right now. Oh, it's a little bit better if I'm bouncing. Dude. Oh. What else you got? I'm not gonna do this forever. That is a little fun. Oh. You want cosecant squared x over 2? Well, if you just make a pretty straight substitution for that, like you could make a pretty straight substitution where u equals x over 2, which means du equals 1/2 dx, which means that equals 2 du. We get integral 2 integral cosecant squared u du, which is going to be negative 2 cotangent of u. So negative 2, cotangent of x over 2. Well, I just kind of did that, but yes, x over 2 would be your u. That's what you would want in that case. Sorry I didn't see that before, I just did it. I think I said this before, I don't have a setup yet where I can do the math and watch the chat at the same time yet. Still need to figure that one out. Again, yeah, you don't have to be like super silent. You can like continue to watch basketball. It doesn't really like affect this too much. Check the noise levels. What you going for there, Arthur? Just trying to like adventure over the side. Adventure. No, that second person is you. Well,
I just logged into it right now to.
Wonder how.
So that you can see the chat.
Yeah. But then you don't have like anything.
Oh.
Okay. That's interesting because it says on yours that there's 3 people watching. Yeah, it says there's 2 people watching. I guess my. Ah, hey guy. So 4x to the third. Okay, yeah, I know that one. Cool. Yeah, if u is x to the 4th, then what's du? Yeah, u equals x to the 4th, that's on the right track. You'd have to go and you'd figure out du, which is 4x to the 3rd. Yeah, there you go. And hey, you have a 4x to the 3rd dx, right? So if you do that, your integral becomes suddenly integral of sine of u du, which is pretty straightforward, I think. Yeah. Why are you coming to me with questions, Lima? You should teach the class. Yeah, I know. But yeah, we should just finish it, you know. You have that, you finish it up. Integral sign is, of course, negative cosine of u plus c. So we're going to have negative cosine of x to the 4th plus c. Hey, up. They're like kind of half crying. Yes, the antiderivative of sine is negative cosine. Yeah, I mean, I don't know what's exactly involved in all these message things and managing it. Sorry, my baby is headbutting me, so I've got to... What do you need, bud?
Take him?
Do you need more? Just a little bit. You want a perp puff one?
Probably. When did you last have a diaper? That's been a while, right?
It hasn't been that long.
Okay. Oh yeah, that's right.
Oh, we got Christina on the stream. Let's just... No, I know, Halima. It's all good. Ask your questions. Arthur is busy.
Playing with mommy.
Playing with mom. What you got for me, Christina?
I'm sweating after being with daddy, huh?
Probably, yeah. What? Huh. I've never...
Oh, thank you. Thank you.
See. Yes, I do save live feeds. And you can see the last one. I think it's archived. Integral of 5 over... Oh, yeah, sure. 5 over the square root of 9 minus x squared. Alright, so this one you want to look around. Anytime you've got a square root and then in that minus x squared, there's like a couple likely things it could be. You want to check. And basically the tell of what it is you look up here, and if you see a factor of x, then you should just substitute.
Yeah.
But if you don't see a factor of x, then that's going to be an inverse trig function. But this is going to require kind of a lot of work before we can see which inverse trig function, or like a lot of work before we know exactly how it's going to go down. Anything over square root of 9 minus something minus x squared, we think it's probably going to be sine inverse. And so we're going to treat it like that and just think like, well, to make it exactly like sine inverse, this 5, we should take that out, but that's easy. Over square root of 9 minus x squared dx. And then the next problem is with this 9. We're going to do a trick that I've been demonstrating a couple times before, is that you factor this 9 out from both terms, even though this one doesn't have a 9 in it. So when you do that, I'm going to write it a little bit bigger. You get 9, 1 minus x squared over 9 dx. Once you have it like that, you can take the square root of this 9, and that's going to be 3. So you're going to have 5/3 out front. And then you're going to have 1 over the square root of 1 minus, and this is the last kind of trick. You got x squared over 9, but 9 is 3 squared. So that's x over 3 squared dx. Excellent. So at that point, we're ready and we can make a u substitution where u equals x over 3, du equals 1/3 dx, so then 3 du equals dx. And this becomes 5/3 integral 1 over the square root of 1 minus u squared 3 times du. This 3 and this 3 cancel, and you get 5 sine inverse of u plus c. So that's 5 sine inverse of x over 3 plus c. And yeah, I think I answered this earlier, Halima, but yes, you can go back and watch the live feeds, and you can even see like the comments, the chat that goes along with them. In fact, I showed that off like the day after we did it, and you can. They're in a. I made a special playlist for them on my YouTube homepage. A problem before that I need help with. So before that, you mean on the festival? It's hard for me to guess, but no on the chat. Problem before that you need help with on the chat. So like one of the ones that was asked earlier. Y squared root y dy. Probably. Okay. Well, that one you should want to treat just as a power rule kind of situation. Oh yeah, that is one of those. So one of the things about that is we're going to change our square root of y into y to the 1/2. So this becomes the integral of y squared y to the 1/2 dy. and it's not really multiplying it out, it's combining them. So if you have two terms with the same base, you can add the exponents. So that would be integral, so that would be y to the 5 halves dy. And at that point, you can just use the power rule. So that would be y to the 7 halves, 7. 7 halves, and then there's 2/7 of that, plus c. My stylus is working weird. What's he doing? Oh, okay.
Like a lot. Like all of it.
Does that seem reasonable, Christina? Oh, my boy. We may have to take a break and settle Arthur down in a little bit if this doesn't. Someone's in here watching on their phone. All right, sweet. Yeah, I mean, he's fine. He's just being fussy. This is usually when he gets fussiest. He's not really a fussy baby. But right before, right in the region from like 6:30 to 7:30 is when he gets really thing. I was trying to do a skull and crossbones, but I don't think that worked out. All right. They just end up looking like that. All right. Well, you know, I am here for you guys. You got questions? You don't have to wait till I'm done answering to ask them. You can load up a queue. I wonder if I can make that like a queue. I don't know. That'd be good. In the meantime, No, I haven't talked with Mr. Sure about how much the festival is worth. Um, like I am doing this so that you get good. However much he wants that to reflect in the grade book. If he, if he were to talk to me about it, maybe I'd have opinions. But we'll probably get to that. Pretty much do intend to grade them when you turn them in, so they're not just like to do it. Like I want you to know whether you've done them right or wrong, which I know is like committing myself to grading 270 problems. But you know, I've got the answer key already made up. I had that made the day I made the festival, so you know, it'll be fine. I mean, yeah, that's an option. Uh, and maybe like you know, I still could do that. Part of this is like the struggle though. Like I want you to be able to look at these and be like, oh, there's actually kind of a lot of different options that these could end up being. And so like that is an issue, right? That we could have again, it's like on the AP is that there's a bunch of different possibilities, and it's only by just kind of doing them that you have any kind of hope of getting it right. In the meantime, I'd love to have questions, specific questions, so I'm not just drawing like skeletons. But I do like drawing skeletons. Anyways, you got me here. I'm just giving away answers. Is it okay if you have a mini lesson on slope fields? Oh, slope fields? Yeah, slope fields are one of those weird things for you guys that there's so little to them, and yet they have to be there, right? So slope fields are kind of a topic of you're in a situation where you have what's called a differential equation, and they pitch slope fields as something that kind of comes before like being able to solve differential equations, which I'm not necessarily about. So by the time like we got to slope fields, most of the ones like you saw one. So dy dx equals negative x over y, right? So in this case, we have enough tools in our capability to separate the variables
and then integrate both sides and realize that this is going to be y squared over 2 equals negative x squared over 2 plus c, right? But say say you didn't have that knowledge, or say this was a differential equation that couldn't necessarily be solved with the techniques we've been going over so far. What could you do? Well, one of the things you could do is we know this gives us the derivative, so the slope of our function at any point, right? Because we have x, we have y. That's enough to tell it, like, you can plug in any point combination and get a slope here, right? So if you just kind of sketch out a graph for 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You can know that it's like, oh, if you look at this, anytime y is 0, that means you have slope that's undetermined, right? So along this line, it's actually kind of convenient. We're going to have completely vertical slopes, right? Which doesn't happen in a function, but in this case, like when you're given a differential equation like this, it's not necessarily a function. This can be a relation that doesn't, that's only a function locally, and that's fine for derivatives. We can also tell that anytime x is 0, then the slope is going to be 0. So again, it's kind of convenient. The slope is going to be 0 all along this axis, right? And so you make these little tick marks indicating like, well, if the function goes through here, it's got to have a slope of basically 0. So it has to like have this like little thing to it. And then you can kind of like branch out, right? So if we're at like 1, 1, you plug in 1, 1, 1 divided by 1 is 1, so you get negative 1 as your slope. So you can kind of put in a little negative 1 there, right? You go over here to negative 1, 1, that becomes positive 1. When you kind of fill in the slopes, you get this kind of like, oh, you can see from this that if we started here, we'd go a little bit here and kind of circle around, right? Which is fitting because this, when you multiply everything by 2, you would get y squared equals negative x squared plus c, so that y squared plus x squared equals c, right? This is the equation of a circle, so we should get a circle, right? And then you can see this as you spread this out, you will end up getting, I should probably be a little bit more honest with these. Right, and so you kind of get this sense like, oh, as you fill in more of the slope field, like you get even this more idea that, oh, hey, this is a circular pattern, right? Which you could find out again using the analytical methods we've dealt, but it kind of helps to know that it's like, oh, this is how it goes, and you can kind of fill in the behavior. Now when you take this to maybe something that doesn't have, will this be on the AP test? Yeah, you can bet pretty well this will be on the AP test. The way I see it the most on the AP test, there is situations. So there's situations like you saw on the GP today, right? Where it's like, you know, which of these slope fields, and I can't draw slope fields that quickly, right? They'll give you a differential equation and ask, like, which slope field looks like it matches this differential equation. Like, or they'll give you a slope field and ask, which differential equation does this look like it matches? But again, on an AP test, I would only expect, like, maybe one multiple choice question. The big problem on the AP test, actually, if this shows up, is if it shows up in the long answer, or the free response, sorry. So this might show up on the free response where you're given like dy, dx. I don't think they usually give solvable ones. Maybe they do. Where they give something like dy dx equals x minus y, right? Not a solvable function. And they'll say on this, and they'll actually put dots. Usually it's something like, they don't put many. So they'll usually put a graph like this many dots. Maybe they'll put in some negatives, right? Why not? And I'll say draw a slope field for this differential equation. And so you'd have to go through, and I'll give you a program that generates differential equations that'll make these kinds of questions super easy. But it's less about being easy, and this is just extremely tedious. Yeah. Yeah.
I just have to go to the store.
Oh, yeah. I'll be ending this, I think, pretty shortly. I've been doing it for an hour. So you have this, and you just generate like a slope. It's like, oh, x. You go in each one. So like when x and y are 0, this is gonna have a slope of 0. So you just draw a little. Actually, I'm just gonna change the color. Oops. Floor 1. Sorry, I didn't mean to get rid of all that. The back one for both. Let's say that's what I had. Yes. Okay. Well, anyways, so you make a little 0 mark there, and then you move over to this one where x is 1 and y is 0. Well, when x is 1 and y is 0, 1 minus 0 is 1. And then you kind of go through. It's like, oh, when x equals y, it's going to be 0 anyways. So at here and here, it's going to be 0. X is 0, y is -1. And that. When x is 1, y is -1, it's going to be 2. Oh my god. And then you kind of go up. Oh, when x is 0 and y is 1, like this will be -1. And kind of similarly here, you get, there's kind of a pattern. So this is our slope field, like a mini slope field, right? And so you'd be like, oh, here's our mini slope field. T cubed root of t minus 4 dt. So like that? Is that what you're looking for? All right. So with this one, we're going to start with a substitution, where u is t minus 4. We're going to find out that du is, of course, dt, which is convenient for us,
but we still have this dangling factor of t. So we're going to go through and we're going to say that, oh, t is going to be u plus 4. Oh, I know. So then we have enough stuff to substitute it all in. So we'd have the integral of u plus 4 cube root of u du. Which, when you include the parentheses, you can take this cube root and distribute. Excuse me. Oh my god. Oh. Okay. Does that help? All right. And in this case, once you're there, you're going to use change this into a fractional power. U to the first times u to the 1/3. It's going to be u to the 4/3. And then we got plus 4u to the 1/3. And at that point, you can finally integrate. This guy, he's just being very fussy. Alright. I think I'm going to make this the last question of the night, by the way. Because I have a baby to take care of. Anyways, when you do this, use the power rule. Add 1 to this power, you get u to the 7/3. And then you multiply that by 3/7. This one you get u to the 4/3. And then 4 times 3/4 is just 3. When we substitute back, we get 3/7. Substitute back. T minus 4 to the 7/3 plus 3. T minus 4 to the 4/3 plus C. Oh, I narrated that, so that's okay. Alright. Well, I've been doing this for about an hour, and I hope those were the essential questions. So I'm going to log off at this point, and I'm glad at least a couple people could stop by. Thanks for doing so.